Actually, use the formula to determine which cells to format. I'm going to say if I'm here, if the present value is negative, let's get rid of these. Actually, no, I don't want to do that. Just a second. I do. If. If that happens, I want to have a bright red background. Okay. And I'm going to copy. So let's make this 5. Suppose. So I immediately know which cells I zeroed out. Now I need to compensate for that, right? Which means I need to add up present values of all negative, uh, all years with negative present value. We have a nice little function in Excel. It's called SUMIF. As the name suggests, it does a sum if certain things happen. It has 3 arguments. Let's do Control A. The first argument is the range where you're going to do the check. In this case, here, all of these. What's my criteria? You put that as a under quote signs, less than 0. So if the appropriate row for that column is negative, then you're going to add them up. And where are you adding? In this case, I'm going to add the present values, but the addition that you make does not even have to be on that column. But in this case, it is. Voila. My original negative PV was period 0 anyway. To that, it adds the present value from year 3, which is 12,421, and from year 5, 2260. So that's essentially a modified cost of the project. I just took future negative cash flows, brought them into today. Okay, that's all I did. I mean, sometimes future cash flows are negative, not because you don't get anything positive, but what you're getting is not enough to cover the costs. If you know that information, you can actually separate them, leave the positive stuff in there, but calculate the present value of the negative stuff and add it to the initial cost. Either way, I have a set of modified cash flows, which are by definition conventional, because there are no negative future cash flows, which means if I calculated an IRR for that, by its very definition, it exists and it's unique. That's what we call modified internal rate of return. So I'm gonna copy this. Let me purple that, and I'm gonna make this black. Why? Because I can. And all I have to do is calculate the IRR for all of these. I don't even have to be careful about what I had to be careful before, because by definition, for years beyond the life of the project, those are zero to begin with. So I actually have a number, okay? The MER over, in this case, negative 856. But if I looked at my IRR, it's negative 56. In fact, in this case, I have three sign changes. Let me see. One, two, three, four sign changes. There could be up to four real solutions on this one. Okay. Like, let me see if I have alternative solutions to this. If I, yeah, negative 28 is also a solution. Yeah, negative 28 and negative 56 are alternative solutions. Of course, they're meaningless because there are multiple one of them. I mean, if this was an advanced class, I could have written a little function that calculated all of the solutions, but I won't do it because it actually needs matrix algebra. You guys know anything about matrix algebra? It's basically a system that you use to solve multiple simultaneous equations. Remember, you used to solve two equations into unknowns? Well, I, I am able to do it using computer programming, 1,000 equations and 1,000 unknowns. In fact, most of these large language models and stuff, they are all based on solution of large systems of equations. In fact, large language models have sometimes billions of variables. That's why you need those chips. Just to give you an idea, if you go from 1,000 variable model to a million variable model, the cost of the computer cost of making those calculations increases by the square of number of variables. So your computational burden goes from goes 1 million times. If you got a billion variables, thousand to billion is 1 million. 1 million times 1 million is 1 quadrillion. Okay? Yeah, 1 quadrillion. That's why you need these massively parallel systems. Of course, in those systems, you have a lot of zeros that take special care of it, but you basically need one mother and a massive army of little ants that does only one calculation for you and report them back to the main brain. That's what artificial intelligence models do, or data center models do. But we don't need that. All we need is our MER. If I made this maybe, okay, I mean, it still gives me that as solution. That's another solution too. Maybe, I don't know. Yeah, apparently there are two solutions in this case. So decision rule with modified IRR is the same. If modified IRR is greater than the cost of capital, you accept, otherwise you don't. All we did is came up with a number that looks like a rate of return by Turking the problem in a sense. For a non-Star Trekkie, turking does not mean anything, but it is a verb, just like Googling has become a verb. All right. Let's stop here. Next week, we're going to cover chapter 6. I'm going to post your chapter 5 homework, which is going to be basically making a lot of calculations like these and interpreting what the numbers mean on Monday. But you have until next Thursday to do chapter 3 stuff.
How do I know which group I'm in again?
If you go to
The email.
if you go to Google folders,
Uh-huh.
there should be a file. Go to the main folder.
Oh, I went on there.
Groups
Oh, I
that
see.
select.
Appreciate
Open
it.
that.
Yeah.
It tells you what your group is.